Friends, today's topic is another important topic, and it is going to be very interesting as well. Um, we have seen many times that rotating shafts are clamped on the flanges by means of bolt, and during engagement of bolts, sometimes one or two bolt found missing or not put on the shaft. In that case, what may happen, the consequence of safety factor as well as performance factor we'll discuss in this topic. Okay, suppose here is a rotating shaft with which is having 4 number of bolts. It is designed for 4 number of bolts. 2 flanges shafts are designed to connect by means of 4 number of bolts at 20 mm diameter each. In a bolt circle, this is the bolt circle. Okay, this is the bolt circle. In a bolt circle of radius 75 mm in equal distance, the permissible average shear stress is given 100 Newton per mm square. What will be the safety effect of torque if one bolt is found missing? Say it may be 1 bolt or 2 bolt. What may be the consequences? Say in this figure, we are putting the bolt. Let us take, here we are putting 4 bolt, one diagonally opposite in the equal pace. Okay, in the question it is given the distance from the center is, that is radius is 75 mm and diameter of the bolt is 20 mm. So what will be the effect? First of all, let us see what is the design shear forces and design torque for this arrangement, and accordingly we can calculate the missing one. First of all, it is shear force for each one. For each bolt you can calculate 2 things. One is shear force, say shear force that will be given permissible average stress, that is Fs, into area of bolt, that is pi d square divided by 4. Permissible shear stress is given 100, pi is 3.14 and d is given 20 square divided by 4. So this will give you 314,15927 Newton. In kilonewton it will be 31.4x kilonewton force. So this is actually design force for single bolt. So how much torque each bolt can take? So design torque will be how much? That is force into distance radius. That's mean it will be 31.416 kilonewton into distance is 75 mm, means 0.075 meter. It will give you 2.356 kilonewton meter. This will be design torque and design force for each bolt. Now we are using how many bolt? 4 bolt. 1, 2, 3, 4. So how much will be the total design force? So design shear force will be how much? Say it will be 4 volt. So 1 is 31.416 kilonewton. Total will be 125.664 kilonewton. If we convert them into torque, it will be nearby 12.6 ton. Okay, this is actually design force. Means if you put all the 4 bolts, the entire shaft can take the shear forces of 125.66 kilonewton or approximately 13 ton forces. It is designed for 13 ton forces. So how much torque it can bear when it is rotating? So we have to consider the torque also. In this case, torque will be seems force into distance. Okay, so 125.664 into distance is 0.075. So this will give you 9.425 kilonewton meter, approximately 94.5 kg meter. So this entire things or entire shaft mechanism is built or designed for taking the load of 12.6 ton or 125.66 kilonewton forces, as well as it is for 94.5 kg meter force or 9.425 kilonewton meter torque. Now in this case, if we remove, say it is given one bolt or 2 bolt. Now say you don't put 2 bolt. Will take your torque for 1 bolt. I am taking it 2 bolt missing. Say 2 bolt missing. In this case, what will happen? Now remaining torque to be taken by the design torque to be taken by only 2 bolt. Say we are putting 1 bolt here, another bolt here. This 2 bolt has to take the entire torque and entire force. So sharing of force by 2 bolt will be how much? Each is sharing 31.415. So now it will be same will be shared by single 2 bolt. 2 bolt will share how much? 31.416 equal to 62.832 kilonewton. Means only 50% can be shared with the same bolt, 20 mm square dia bolt. Okay, for 2 bolt. Okay, only similarly torque will be twice of single one. Torque will be, what is single? 2.356. 2.356. It will give you 4.712 kilonewton per meter. It is also 50%. Only 50% can be borne by these 2 bolt. So another 50% will not be there. So this will be devastating effect. Means if 50% load cannot be shared by the shaft, there will be effect will cause it to damage, or there will something factor will come, it can shear off, and nearby person who is working can hit and cause the injuries also, as well as the entire equipment can be damaged. The damage of the equipment and damage the person working nearby. So we should not keep the shaft left with uh, bolt, unfound bolt or not available bolt, we should find out the bolt and put all the bolt together. Sometimes we are using winch machine where the shaft is connected by 4 bolt. We may notice that only 2 or 3 bolts are there. 1 or 2 bolts are missing. In that case, it will be dangerous. It can shear off and hit the operator or somebody nearby, or as well as shaft can be broken and the load can be falling. So you should notice this effect. On if we lose 2 bolt, it will be 50%. It will lose 3, which will short of 1 bolt. It can give 75% of sharing of the design load. So it is not acceptable. Okay. So last but not least, so suppose to overcome this, what design of the bolt is required? So now I are using 20 mm dia bolt. Now say same amount of load has to be shared by 2 bolt. If we need to fix with the 2 bolts only, so we will see what will be the required dia in that case. Okay, so required dia in this case, shear strength will be the factor of safety pi by d square divided by 4. So this has to share what? Twice of the load in this case. Okay, single bolt is sharing whatever the force it is sharing by single bolt, it has to be taken by 2. So double of the force has been given to the single bolt in this case. So 2 into 314 15.927. Okay, so this will be double of the force to be borne by single bolt in this case. So what will be the value of D here? F it is 100, Fs is 100, pi is 3.14, 4 d square 2 into 31415.927 Newton. Okay, we will cancel this, put 4 here, cancel this, put 314 here. So ultimately this square will be approximately 800.40. So what is the value of D? If you square root this, 800.40 will give you 28.29 mm. So required dia of the bolt will be bigger than this, almost 1.5 times bigger. It is 20 mm dia. Now you need somewhere 30 mm dia. So you need some bigger bolt, almost 1.5 times. So your entire system here, the design has to change. So whenever you are fixing the shaft, remember this factor. Don't use with short number of bolts. It is concern of safety factor. Thank you for watching. I think it will be helpful for you.